Let's solve this system of 4 equations with 4 unknowns. It's a quadratic system, so we could start with the determinant to see whether there's a unique solution or not, but we go straight into creating augmented matrix. So first column coefficients with x, second column coefficients next to y, third column coefficients with z, and fourth column coefficients of t. This is a homogeneous system, so the right hand side are all zeros. Shouldn't say so, because the right hand side are all zeros. Now we're going to use the Gauss-Jordan method with pivoting, which gives us full freedom in choosing our pivots. There's a whole bunch of ones. The first 2 columns have zeros in them. So I would choose one of the elements in the first or second column just to reduce the amount of work. And let's say I'm gonna take this one. So what I have to do is I need to eliminate the first entry in the first row and the first entry in the fourth row. So from row 1 I'm gonna subtract twice row 3, and from row 4 just subtract row 3. Okay, the third and second row will stay unchanged, so we can start with just copying those two. And now we subtract this. Oh, this last column will be all zeros, so I can fill them in. So now we have 2 minus 2, which will of course be 0, 1 minus 2 is 1, minus 1 minus 2, negative 3, and 1 plus 2 is a 3. Last row, just subtract 1 minus 1, 0, negative 1, negative 3, 3. Okay, now if you take a closer look, you can see that the first, second, and fourth row are pretty much the same. First and fourth are identical. The second is just a negative multiple of first or fourth. So they should be reduced, so we should get 2 rows of zeros. We choose our next pivot, which of course I start with covering the third row in which I have my first pivot. So, because I don't want to mess anything up by making a wrong choice. And then one of the uncovered entries is my pivot. Choose one of the ones, probably not a 3. Say this one. Okay, so we eliminate the whole column in one step, which means just to row 1 we have to add row 2. To get rid of 1 from row 3, subtract, and to remove negative 1 from row 4, add row 2. Okay. Now second row doesn't change, so start with rewriting it so as to have points of reference for the remaining entries. And here we add, we have a whole bunch of zeros. In the last row when we add, we're gonna have a whole row of zeros. And the third row we subtract. So 1 minus 3 minus 2 plus 3, so 2 and 0. Now we have 2 pivot columns, first and second, and 2 non-zero rows, which means our elimination is done. The number of pivot columns equals the number of non-zero rows. Now the first 2 columns are the pivot columns. They point to basic variables, which in this case are x and y. And the third and fourth are non-pivot columns, so they corresponds to free variables or parameters, which in this case are z and t. And from this augmented matrix we can now write down the equations, just like in the first step. From the system we write the matrix, here from the matrix we write the system. Second equation we have y plus 3z minus 3t equals 0. Third row, third equation, we have x minus 2z plus 2t equal 0. That's the system, and from this one we can solve for the basic variables, which are x and y. So from the second equation here, x is 2z minus 2t, and from the first equation, y is gonna be minus 3z plus 3t. Z and t are parameters, free variables, so they can take on any real values. We have a system which has infinitely many solutions with two parameters.